So it might be about 20 times he plays this mantra. And then this is kind of like the sound left over. So it's kind of like the room itself. It's kind of cool picture right here. It's like zooming in on space to represent this concept of zooming into the room's acoustic signature. You can get the same effect if you just put a Xerox on a Xerox machine, and then take a Xerox of that, take a Xerox of that, and then slowly everything just breaks down. It's kind of warm and fuzzy by the end. But this could be a good example of cybernetic music in a way, because it's all about feedback. Not necessarily feedback controlled, but definitely an experiment into how far feedback can go. There's a nearly famous artist named Leo Viorelli. He's the guy that's doing the Bay Lights project. Like many artists these days, he just works in LEDs, but his particular work is kind of a little bit more inspiring than everyone else's, perhaps, because he's using generative, either algorithms or just systems to get these combinations. It's kind of hard to time share a microprocessor or a computer processor to control hundreds of thousands of lights. So his software might be, or his hardware might not be giving much precedence to individual control, but just kind of setting up chain reactions. Or I hear that his work, like the best stuff, like what we're seeing here right now, is he just like chose particularly this part to share with us, because like 90% of this thing's performance is just kind of crazy and chaotic, and not necessarily like artistic or expressive, just kind of out there. And so it's kind of like Shakespeare's, or the monkeys that can write Shakespeare. Like if you just let millions of monkeys write at typewriters, you're bound to get something interesting, or the exact work of Shakespeare, if you wait long enough. So luckily artists can just tape record 1,000 hours of their art and then just show you the best couple minutes. But generative programming or hardware is his thing. So he's not necessarily in control of the system so much as just influencing kind of like a black box that's in charge. And it might save on processing. It might save on the programs. It might just be extra redundant to have a program that plays everything you want, whereas you could just have things happen without your choice. And it'd almost be
traffic moving back and forth. We have boats, and they're very site specific. It's taking QD nodes spaced every foot.
So you wired up the Bay Bridge recently. It's going to be on for another year, perhaps.
Each node will be individually addressable. So this is a very unique way to light a bridge. There's been a lot of illuminations of bridges, but never quite like this. This is something that's intelligent and smart. I think when people see this work, virtual reality, interactive television, which brought me out to the Bay Area to work at a research lab called Interval Research. It took me a long time to find that light would be my medium. The effect my work has is really to bring things to life and to activate spaces. So the pieces have a lot of personality, and I think viewers really identify a lot of things that you would see in nature, for instance, in the sequences that you see. So you start attributing different qualities to the pieces, but then the pieces begin to shift and change and become something else. So there's a fluid quality to them, and just as you start to get an idea of what it is, it starts to shift and change. So there's a slipperiness to it, but it's very pleasing to unravel these pieces, and really they're all about time.
So I wanted to present some more on kites. I don't think I have anything prepared on kites today, but if you just check out the Wikipedia, there's it's like its own class if you wanted to. There's 26 different types of kites. at least. There's a general glossary of concepts around kite design. The biggest kite ever made was by a guy named Peter Lynn. I mean, just from the start, they're kinetic, so you hardly need to even add bearings or any rotating systems. It's just enough to get it in the sky, perhaps. But it's almost the same thing as inflatable design. Probably have to work with ripstop nylon and get used to nodal placement of all the strings.
Walter de Maria in 1977.
The lightning field.
Walter was born on October 1st, 1935, in Albany, California. Primarily involved visual arts, literature, theater, in him using simple geometric shapes and industrially manufactured.
He's just reading this from a piece of paper.
Stainless steel and aluminum materials in his designs. He's the founder of minimalism, which means he uses a more simplistic approach to his designs. The lightning field is situated in a flat plain, 7,200 feet above sea level. The area is 1 mile by 1 kilometer. There are 400 stainless steel poles whose peaks form an exactly even plane. The poles average 20 feet and 7.5 inches in height and are tuned at different.
So that's the hardest technical challenge of this. You had to use surveyors and do exact laser measurements because the ground's uneven, but he wanted the surface of the top of the lightning poles to be even. So say some are 18 feet, some are 25 feet, all to equalize for the sky. And in theory, if they're all the same height, then they're pretty much all equally probable to be the one that's hit. So this really takes advantage of the kind of like geomantic principles of the Earth. It's kind of like a hack of a storm. So Gary's Hill stuff you saw. Let's see if the new stuff loads. So today's lecture focus is kind of like on the man-machine dichotomy. Some people are trying to really integrate themselves into machines. I don't know why. We'll find out. But early integrations is just transportation, getting functions taken care of. And some idle hands are just going to start playing around with the concepts that are around them. So these guys, I think they're from New York, about the 20s or so. They were a bike repair shop, and they just had enough idle time and enough extra parts to just put on some pretty funny combinations. This particular bike, I hear if you brake too hard, then the inner circle starts to spin. So it's, each one of these is pretty dangerous. The designer of this bike is the one on the top up here. He broke like 2 ribs learning how to ride this bike. All 4 of the chains go back down to the drive. You can see that the top guy goes back to the rear fellow and then down to the bottom. Here's the Gangbusters bike. I think it has like 20-30 guns on it. This picture right here is like they made the bike just in particular so that they could take this picture. I doubt it rides very well. I hear bicycles used to not have pedals, maybe just scooters to sit on. This particular bike, you probably see something like this at Burning Man because it might be intelligible to put spikes on your wheels so that you kind of dig into the sand. This is pretty hilarious. It's a 2-seater bike. It's like a carpool lane bike. This particular one looks just like they made sure that the bed frame was part of the bike, so it doesn't seem to be very. I don't know. It's assemblage. It's finding things and integrating them. On that point, this guy's name is Julio Gonzalez. He was a contemporary of Picasso. They lived in Catalan. And when Picasso was trying to do some collage works with metal, he commissioned Julio to teach him how to weld acetylene welding. Julio worked in a munitions factory during probably World War I, and so he really got a good knowledge of, it's in Spain, really got a good knowledge of the welding form. He also made jewelry. And this work right here is probably Picasso, maybe Picasso alone, maybe with Julio's help. Picasso plays on lots of nice archetypes and like doll forms occasionally. These two on the right, I believe, are Julio's. This is Julio's famous one. It's kind of like I think it's called like the cactus man. But the particularly fascinating thing about Picasso and Julio's work is that it preempted a lot of the work I'll show you today, where people are taking industrial machines and turning them into art. So Julio and Picasso, Pablo, would just find pieces of metal and then kind of shape ideas around what those pieces of metal should be used for in art. And so they have a very raw look. If you ever check out Picasso's, I think it's like a bronze monkey. It's another example of assemblage, but in this case it's about casting. So this very work surface of kind of a mother monkey is actually a particular object. He casted a toy car and then integrated it into the wax of the kind of like hand-formed direct sculpture. And so it's an interesting juxtaposition of an object that's kind of transformed into a character. So it's pulling on the values and the feel of a pre-made object. Picasso's most famous metalwork is just a bull. It's worth like millions of dollars, and all it is a bike seat welded to handlebars. He's the first one to do it, so it's worth $1 million. The second person to do it wouldn't really get that much. Julio Gonzalez's work is only known in retrospect because he was related to Picasso's work. Yeah. But he's the first metal collager. So along the line of kind of like the man-machine, the human versus the mechanism, there's this common trend of trying to integrate your performance with as many machines as possible. Like, what is the upper limit of how much a human can multitask and control in a performance or in expression? And so I brought you a little cross-section of what's referred to as the one-man band. Here's a colonial one, looks like a Spaniard one. It dates back to slightly pre-civilization times. I mean, just a drum and a flute was the first one-man band, one for each hand. A lot of the rigs you'll see have linkages connected to the extensions of, like, say, the guitar. So like the top of the guitar has a linkage that goes to a triangle, the bottom of it has a linkage that goes to a snare. They'll put cables on their biceps and their knees so that they can so that their walking is necessarily translated into a certain kind of rhythm using all their percussion instruments. Some guys go the other way, where they want the assemblage to stand separate from them so they can play their one instrument in duet with mechanical monstrosity. And there's this fellow named David Berman I'll show you a piece of music from. But his claim to fame back in the 80s was pretty much the first computer duet improvisation, so that he would make audio from his flute or whatnot, and that audio would be piped into a computer, and then it would be spectrally analyzed, and then from that the computer would make decisions on how to play, supposedly in unison with the original artist. But a setup like this is probably just read-only memory. You know, there's no improvisation, there's no interactivity between the machine and the human player. Just make sure the memory is loaded correctly. If you haven't played World of Goo, you should probably download it. It's almost free. There's a secret download website, which I could probably help you out finding. I got it a couple years ago. And I'll show you 2 levels. This one in particular inspired me to do some work in AlgoDo. I'll show you how that ended out. But it's a physics sandbox, and your only kind of expressive tool is these goo balls, and you can create linkages with them. They're not necessarily like mechanical linkages, they're more just kind of elastic bands. And they have a certain principle where they want to be kind of like steadily connected. You place one and it predefines which links are going to go there. So you can't necessarily do too much creative stuff with it, only just building. But the physics engine underwriting it, they originally designed the physics engine themselves, and then they just scrapped it because it was getting too hard, and they just used a standard one that was open source. But the principle is you just get your characters, make a bridge to the outlet pipe, and then your characters can go out. Every level's got a different challenge, but this particular one is just the sandbox level. So this guy's just going to grow like a 300 goo tower. The game is mostly based around building towers. Uh-oh. Probably the funnest part of the game is you have to create something that's unstable, and while it's falling, you have to work fast to either stabilize it or to get the goos to finally reach a specific place, be it a ledge or the outlet pipe. So it's a fast game for clicking, kind of like StarCraft's, what's it called, microing or something? Got to micromanage all these different things. This particular video shows off a pretty cool architecture that's got a decent amount of stability. He's got a repetitive system where he just keeps creating this design. Just stack that on itself every time, and it won't end up over too devastatingly. It starts to waver. He's up to 20 meters. Towards the end, he says, "I'm done with the structural stability. I'm just going for height." And so it was falling to the right, and then he just grabbed it and gave it a little bit of a tug so that it stayed to the left. That's an advanced move. And I think all the guys have a little microscopic weight, so maybe he's trying to keep them centered. But one of the funner parts of this game is when something self-destructs, it just turns into a gnarled mess of broken bones. And it's over. So oftentimes once it falls, it's got kind of almost a breathing nervous system from all the reverberations of the shatter. So if you give this next link a click, it'll download a zip file of about 5 AlgoDo files. I think there's only 2 different files, and one's just a redundancy because that's how I like to program, is like whenever you get a milestone you save as, because sometimes you can accidentally save over something that was a little better than what you're growing. I don't know which one to open, but from just the pictures, I was doing a design based on this archaic drawing from a tome. I think the basic principle of this is when it's on its right, it outputs to the right and also outputs through this this release to slowly fill up the other side, and once that gets heavy enough, then that tips over and changes direction. So it's just like a timing alternator. In AlgoDo, I was hoping that there was a kind of like a merge function on the CSG, computer scalable graphics or something. But I didn't find it. I was hoping I could, but all I could do is just weld things together. So all those different trinkets were just fixated together. And from there, all you can do is just say group or ungroup in the select menu, and then you can click on it as one thing. This object right here is actually 3 different objects. They're not connected yet. To connect them, for this particular one, what I ended up doing is just making a square right here, putting on a different collision layer, and then fixating the square that links all 3 parts together into one part. So I was doing some experiments with what water could do. Water has got a specific weight in AlgoDo. You can't modify water. It's got one property that you can modify called like reflectivity, but I have no idea what it does. You can't change atom size or anything. So you pretty much have to design or scale your instruments around what water is set to do. And there's only one kind of water. So if you set up an object that either collides with water or doesn't, it's you can't set up different collision layers of water, which is kind of sad. Why in particular is that sad? Is because I wanted to make this cross boundary, as is declared in this original drawing, that the water runs on 2 different layers. And I couldn't get that to work exactly. I set up this little dirt bike rally so that if something flew down the right, it would get a little bit of jump and keep falling straight, and that worked great. But if both channels are getting water at the same time, then they collide, and it's 50-50 chance that it's going to go anywhere. The next thing I did after trying to redo this ancient valve system was just to make a water gate. So these designs are based on making an AND gate. It's probably worth showing you. I don't think it's exactly complete, because there's a lot of ratios for how much weight the counterbalances have versus how much weight the water's gonna press against them. I was originally trying to just do straight levers, maybe 2-bar linkages to open up the plugs on the bottom, but it wasn't working, so I changed over to a chain mechanism that hoisted up the counterweight. And then the left side and the right side are about exactly the same. So different stuff going on in the most recently modified. I set up tumblers. This is just like the tumbler level in World of Goop. The first one I set up was a circle, and then make a little circle inside, and then do CSG to make it so you have an outer rim, and then set up like the background to be like collision layer 2, the outer rim to be collision layer 1. You can just turn off the collision layers that aren't even relevant. And so I set up this little tumbler, put my name inside of it, hand drew all those pieces, and gave them inner zones with CSG. But I wasn't getting any luck, and so I did it all again, but this time I used a gear. And I didn't use a gear because I was doing any gear ratio stuff. I just wanted friction on the inner ring. So that's how you make a washing machine. It's kind of fun if you just take the physical structure of letters and drawings and have those interact with each other. So you can pretty easily create words and then release those words in a gravity field and then see what happens. It's kind of fun when almost like poetry is rewriting itself. The poet William Burroughs created a more recent version of the cut up. It's an old Dadaist method of poetry where you just Tristan Tzara back in 1910, he would just cut up pieces of newspaper and then drop them out of a velvet bag, and then you get a new story. William Burroughs' style was to do compositions. He was a writer, and then just cut the papers in half, and then just slide the left and right sides of papers up and down until you got a new sentence. And like a lot of these systems, you can just generate thousands of different combinations of the chaos, and then just kind of muse over them until you find one that's interesting. So I wrote the word "and" gate up here, and then I pressed space and it started to roll. And it was funny when like the D started to bend over and try to knock over other parts of the word. So to get this one to work, you just drop a square in it, bring up your menu, and liquefy it. And it plummets through if there's enough weight, and hopefully offsets this this counterbalance thing. That's intention is that if there is no water, then it closes. I think this one in particular is like a, if it's open, then it's closed, so it's kind of a not and. So I was trying it with this 2-bar linkage, giving it a blockade here and a blockade here. These two are just for the little mechanics to get trapped in this little wedge corner. But it wasn't working out perfectly. So I tried this method. Once this one opens, then you see one of the balances goes off if this one opens and the other one does. So they're completely independent and they're running on 2 chains. The problem with this design so far is just getting the ratios down for the weights. I turned down the weight of all the objects down here, but this particular one, it's got like a 1 or 2 kilo weight. So ideally you want it when there is stuff liquefied up here, there's enough weight to let that through. So there isn't at this time, so I could take this one, turn its density down, and then it opens. Great, that's what it's supposed to do. But the other thing is that when it's in the closed state, you don't want it so that any amount of water in this zone has enough weight to, as you can see, this one's in the closed state, but it's letting stuff through. So ideally that would require you to make this heavier, which closes it, fights against the water. Water's got a constant weight, which you can't really do anything about. So I noticed this chain fell out. It used to be over, sometimes chains fall through their collision detection things. Kind of annoying. So still working on getting the instructions perfect on this machine. The one trick I was trying for a while was, if this is opening, then it's got a certain rotation that it's influencing this thing on. So I was putting a little, if you put a little like dot right here and give it a fixate, then in theory maybe like the push that the water is going to give the weight is going to ask the weight to move, say, this way. So maybe if you had a stopper that stopped that kind of movement, but you don't want a stopper to interfere with this thing being able to move up. So for this system, it seems you just got to balance the value of the weights versus the water, as well as maybe put stops where the water wouldn't be able to override the stop, but the spring lever would. So it's almost done. And once it is, then you can nest them, because in AlgoDo it's the simplest thing to mass produce something. Use copy and paste. I don't know why the instructions come up when you paste. So you could have water jump through this one down into this one and set up giant chain reactions that are about this big. And this principal mechanism would work probably for every kind of gate. You just probably need different sized blockades to interact with the water. So right now, of course, these gates close when there's no weight and open when there's weight. But if you set them up differently, then you can make other kinds of gates spatially. So I think all of those 2 or 3 programs are all wrapped in to the most recent save. The early version of the double weight machines are hanging out here. You can see this overlap system. It's like, right now it's like 80% efficient. It's kind of funny. But that's the limit of AlgoDo, one-dimensional, two-dimensional water movement. And I made these little valves that you can just manually move in and out. On the bottom down here, you can see I got these side notches. Those are intended so that when the weight falls down, then if it's just right, then it tips open to the left, and then stuff can empty out. But you need lots of precise little blockades to get it right. But it's kind of cool. Just the two-dimensional shape of a bowl is enough to hold water in this program. And here's an example of fixating something that's just to hold like the welds together of distinctly different objects. On this one, you see this is the weld that had to connect 1, 2, 3, 4, 5, 6 parts together. And then there's one fulcrum up on top. So I think it's worth just keeping the aesthetic of AlgoDo messy. That way, at least things are visible. A lot of the universal downloads you can get are very clean cut, and it's hard to know what layers are on what effects. The predecessor to AlgoDo was called Fun. I've included a link to a Rube Goldberg competition they had in Fun. So you got bounciness and fulcrums. This rack down here might have been manually designed because I don't think there's a rack in AlgoDo. They made their own pull cue inside of these 3 different sets of rollers. Size can be deceptive because a big object like this could have absolutely no weight. There's 1 or 2 rules in AlgoDo that you can set in the preferences for every object. You can make something immortal, or you can make something a killer. And of course, a killer means that if it touches another object, then that object goes away. So that was a killer of the gate right here. He had to help that one out. Some people have made roller coaster models in EMBODY. I think one or two people have made slightly realistic, complete video games, but it's just missing a couple instructions and control commands to really make it a video game engine. A little bit back to the human and the computer. This album by Kraftwerk back in 1986 had this big visual art design system. It says right here, Rebecca Allen over at the Institute of Tech in New York in 86. It took 2 years to complete this whole thing, but they did a spatial mapping of the four guys' face, and then they did the music video with animated mouths for these characters saying the song. But Kraftwerk in general, their whole aesthetic was about how humans are kind of robots, and most music's pretty boring time signatures, repetitive and all, so they're just kind of playing on machines and how they're periodic, and humans and how the music they sometimes want to listen to is very repetitive. But they kind of invented techno, so check them out. David Rokeby is a cool guy. He's come through Santa Cruz a couple times. I've seen him. He did a art presentation of his piece called Taken in the Cezanne Gallery, like 10 years ago. But in the 80s, he was designing stuff that is on everyone's computer now with the Kinect. So he's just being watched by a camera right now in the 80s. This system's called BMS. It's kind of funny to play on nervous system, so it's called the very nervous system. And it's a plugin for MaxMSD. I don't think it's a standalone. And supposedly just camera in, and it can somehow decode your motion to, on a couple different dimensions, give you a couple numbers that can help you control sample times, sample starts. But in music design or like instrument design, usually there's just triggers, like it's on or it's off, started or stopped, and then there's just degrees. So you have the fader at any state between like 0 and 127, or you just have a toggle that's either 0 or 1. And so you would think like if the motion of the entire frame is above some threshold, then that would be a trigger to start a sound. And then if it tried its wholeheartedly to just follow a particular hand, and then like say down here would be like 0.7, and up here would be like 2.5 for the speed of the sample. In popular media, they've referred to him as the guy that dances with computers. It's like Kevin Costner, except not wolves. He's from Canada. I think his system BNS might have sold for like $200, $300 bucks. Some artists might have bought it to be able to do stuff like this. But you gotta think about what it's worth. Like if you're a computer artist and you want to do this kind of work, and you just buy like a $200 plugin and get it done for you. And it's just kind of weird. Like going to McDonald's to get Thanksgiving dinner or something. Probably want to be able to do it yourself if you're gonna, take credit for it or feel accomplished. Other systems that I've heard of. There's one called Cyclops. It's kind of old for MaxMSD. It's been made by Eric Singer rather than David Rokeby, who's a New York artist. And then out in France, the one that I'm most fond of is this one called, it's just called CV. And it was a doctoral thesis work that was released as a set of plugins for Max that does blobs detection, a lot of the boring noise stuff. I always resort to it when I want to do dilation. You've seen some of my laser cut pictures and how they just have like rainbow dilations on them. That's just running layers composting through one of the plugins from the cv.jit. Here's a more recent example of David Rokeby's work. But you wonder what he's doing. Is he artistically, skillfully, specifically crafting something, or is he in kind of like a limbo state of like, I'm sort of in control, I don't know what's next, but I'm sort of just going to act like it's happening with me involved. Interactive arts, it's got that fuzzy zone where your confidence could project that it's a more functional system than it is. Here's that piece of music by David Berman I wanted to share. That's a duet between him and a computer. So he's playing the oboe or the flute, and then the computer's playing the synth oscillators. It's a little bit different than what Rokeby's after. Rokeby's saying, like, I'm going to perform the computer as an instrument. Or David's saying, I want the computer to be my friend playing with me. The other line of the song. So you gotta wonder, when does it actually cross that line where a composition is a duet? Because in both situations, just a guy and a computer. Maybe for David Berman, he spent a lot more time, like just at least conceptually, thinking about what it takes to make a conscious, like an aesthetic system for musical creation. Where Rokeby's like, I want a one-to-one relationship between, like, when my hand moves up and down, I want the computer to be able to discreetly be aware of that. So it seems like Berman's after a more hierarchical program that has more like a conceptual state. These days for $100 or less you can get your own Kinect. It's just a USB device that connects to Xboxes regularly, but they've made open source hacks so that the grad students and anyone that wants to have some fun, probably in less than an hour or two of just code installing, can get to this point where they just have a 13-point skeleton on their screen that's slightly aware of who they are. I showed you my puppet system and how what I planned for it was just to be able to put masks on it. And what they do in CGI for every movie these days is they just have a guy wear a color distinct bubble suit, and then they just graph that onto the computer animated characters. Just another random test someone did, how you can take the points and then translate them into kind of like a touch awareness, so that when there's a decent velocity on a specific point, then it outputs to the amazing effect of a fireball. I like this kind of example specifically just because it has the running code in the background. It's kind of fun to think that the stream of numbers is somehow translating. But all this talk about skeletons, probably need to be reminded of a little bit of Theo Jansen's work. He's got a 10-minute TED Talk.
These are made of this kind of tube, electricity tube, we call it in Holland. And we can start a film about that, and we can see a little bit backwards in time.
Eventually, these beasts are going to live in herds on the beaches. Theo Jansen is working hard on this evolution.
I want to put this forms of life on the beaches.
First steps.
And they should survive over there on their own in the future. Learning to live on their own, and it will take a couple of more years to let them walk on their own.
What is he talking about? Are they ever going to walk on their own?
The mechanical beasts will not get their energy from food, but from the wind. The wind will move feathers on their back, which will drive their feet. The beast walks sideways on the wet sand of the beach, with its nose pointed into the wind. This is the Animaris currens ventosa.
That just hurts to watch. TED Talks are such ego strokes.
Right, you can see this one. And now it goes from, yes, now it goes from left to right. And this is a new generation, a new family, which is able to store the wind. So the wings pump up air in lemonade bottles, which are on top of the, and
Drivetrain,
and
lemonade
they can
bottles.
use that energy in case the wind falls away and the tide is coming up, and they still have a little bit of energy to reach the dunes and save their lives, because they are drowned very easily. This animal is very important for the walking. There are 11 numbers, which are called the 11 holy numbers. These are the distances of the tubes, which makes it walk that way. In fact, it's a new invention of the wheel. It works the same as a wheel. The axis of a wheel is staying on the same level, and this hip is staying on the same level as well. In fact, it is better than a wheel, because when you try to drive with your bicycle on the beach, you will notice it's going very, very hard to do. The loads can be moved. There's a guy pushing there behind, but can also walk on the wind very well. It's 3.2 tons.
Did you say 3.2 tons? Looks like cardboard. See this airfoil? Supposedly that's the motion generator.
It's in the bottles. He has a feeler when it can feel obstacles and turn around. And that's what you see is going to the other way.
Alright, so this one actually gets there. It actually transcends. It's got somehow a mechanical apparatus that knows what's in front of it and can react to it. That's actually alive at this point.
Can I have the feeler here? Okay. Good. And this is.
So it's got a cool phonemic system.
It knows always where it is on the beach. So it's a very simple brain. It says, well, there's the sea, there are the dunes, and I'm here.
Yeah, philosophers would have to talk about where the intelligence for this beast actually is. It's probably in those bottles, or maybe it's in the tubes. So a couple of one-man bands I'm gonna show you. Vic Ellis is a big name. He's from Sussex. Kind of a simple getup. His kinematics are just leg strings and back of foot strings. So he might have 4 different automations on his legs. Thank you. the principle is pretty cool, and it's a little bit similar to David Rokeby's Dancing with Computers concept, where you just have trigger points and slacks and extensions that will release the energy onto the objects that are making sound all over you. I like the characters that really max out how many things can happen.
Michael Jackson, yeah. More time.
So his guitar's got a cymbal connected to it. They've come a little way since just having one bang kick drum on the back. This particular guy's got the entire drum set on his back. Do you think he's erratically shaking his head as one of the hits? See those springs? Oh yeah, it's a nice setup. Yeah, so there's no standardization for one-man bands. I'm just a fan of the concept that the dance translates into a particular percussion system. So here's the spatial mapping system back in the 80s when they first tried at it. I think they originally just took photos of the guys from the front, the left, and the right while they're wearing like a dot mesh. Oh yeah, here's the making of part. Facial detection's gone a long way since then. These days, like David Rokeby's stuff, he's just one guy. He was approached by the military back when he was doing his work in the 80s, and they're like, "This is amazing. We should use this for surveillance and whatnot." And they're like, "Tell us more about your system." And he's like, "Well, let me show you the system." And he opens up the velvet rope, opens up the velvet curtain, and there's just like one really old Macintosh just sitting there with open circuit boards. And the military guys are just like, "You're just some hippie. This isn't real, because we only invest in like sophisticated programs that have like really lots of computers. You know, everyone's got to be wearing lab coats." So Rokeby stuff is just a little bit too homebrewed to make sense to the industrial military complex. But if you haven't seen security systems these days, or even just like YouTube algorithms that will follow faces, it's gotten pretty extreme. There's this joke about how if you don't want your face to be detected when you walk in public, you should just hold yourself at a 10-20 degree crook in your neck, and then all the facial detection algorithms that are on security cameras don't know what to do with your configuration. So you just like this all day, then you'll transcend the security devices. And from here, I wanted to show you the most insane guy ever to partake in digital art. His name is, he goes by Stellark. His original name is like Stellius Arctavius or something. But for some strange reason, he's practically like a musician that just really wants to integrate his body into the events. So he usually, like Dan Burn might make a computer that plays music with him, but the recipe for Stellark stuff is, I have a body, I'm going to give half of my body to the computer. And so I am the instrument that I'm sharing with the internet or with servos. So this first piece of work, supposedly, just like you can put a voltage through a frog leg or a squid arm and get it to flail, he embedded a bunch of circuits on his skin so that his body was controlled by the internet. He'd have maybe like 30 tap points representing like internet traffic that would convert his body to involuntarily express or flail.
I mean, this is the first time we've had it on.
He's an Australian guy. His other form of artist work is these things called suspensions, where he just puts flash hooks on himself and just suspends himself over various places. But all through his art, he's trying to transcend the meat of his body. He's trying to install new sensations, new apparatuses that reinvent his identity. He's kind of like that plastic surgery lady Orlan, who wants to just like through a series of like 20 plastic surgeries entirely reinvent her identity using science or synthetic methods. I heard an editor that went to see one of Stellark's pieces, and how supposedly the aesthetic of Stellark is like leave the flesh behind, like it doesn't matter. But when she saw his work, it made her like super aware of the flesh and how it was almost in competition with all these machine parts. And so it's funny how Stellark might say on paper that he's trying to transcend the flesh, but then someone sees his work and says, this is the biggest embodiment of flesh you ever could accomplish. And I know what you're saying. You're saying, what is that thing on his arm? Let's see if this one tells about it. Well, it's called his third hand. Well, that's probably good enough. Yeah, so it's a cybernetic third arm, and supposedly he has like an area on his abdomen that he trained to control the third arm. So he just has like all these sensors on his abdomen that control all the fingers, and he just rewrote his programming in his brain to be able to flinch his muscles to intuitively control the grasp of the arm. And I don't know, it's almost like the equivalent of his favorite synth. Whenever he's got a new show to do, he'll just choose some of these these cybernetic appendages, and then change up the recipe for like, okay, well, like this time I'm gonna have the upper body of me controlled by a computer, and I'll have like my sanity salvaged or preserved because I still have my legs. So he's done another one where he makes like this exoskeleton that controls his upper body. So he has like these phonemic pumps on the back of his arms that make it so he has no control, like physically. The pressure of the phonemics just controls his upper body. And say that's controlled by the internet or like poles or a joystick. So someone walks in the room and just plays the joystick, and then his body has to follow the commands. And the coolest thing he's done with his robotic arm is supposedly with his 3 arms, 1, 2, and 3. He wrote some words. I forget, well, it was like some philosophical word like knowing. But supposedly, like, his first hand drew the N or the K, and then the second hand drew the O, and then his last hand drew the I. So one hand's drawing that, one hand's drawing that, one hand's drawing that. And he trained himself to be able to, write K and O and I all at the same time, and then N and W and N all at the same time. So he'd write long words and just cut them into 3s, and then with his super multitask mind, he's like the one-man band. He would just like perform his muscles and convert it into these words. Looks a little bit like an accordion though. Here's a video of him doing a performance with this giant octopus automaton he helped invent. He's an older man while he's using it in this video, but usually he's naked and he doesn't have his third arm on either this time. But I don't know, he just seems like a boss of a video game at this point. For this particular piece, just like the one where his upper body is controlled, he's on a turntable, and his rotations, I don't think he necessarily controls them. But supposedly he was, for the premiere of this octopod robot, he made it so that his third arm was controlling the movement of the machine. So it's just layers and layers of control. But underneath it all, like you look at his diagrams, and he's just kind of like he's maybe just obsessed about having a performance system, which I can understand. When you perform, you just want to have like a really cool rig, and he's just topped pretty much everyone's rig by integrating his body into it. Now here's another kind of Dances with Computers piece. It's like a choreographed dance for him in a CNC mill. It's sort of like the Nutcracker. I didn't load any videos from him, but there's this one German industrial band named like Neue auf Bauens Einstunde or something. And their particular model for performance often consists of using power tools on the stage, and then the music is dismantling the stage with those power tools. But for some reason this Sellout piece reminded me of that. These are some of the Theo Jansen pieces that I laser cut. You've seen them around the room. I'm going to mention a little bit about Survival Research Laboratory, and then we'll go into some of my electronic art. But it pales in comparison to this nonsense that SRL is doing. So Mark Pauline is this crazy punk from Florida who was trained as a machinist and went back to college during kind of like that midlife crisis point where he was wondering, what am I doing helping the military make 16-ton machines of death and destruction and exploitation? I don't think this is worth it. I don't care how big the paycheck is. It's just I'm just a slave to this military industrial complex. So he decided to, in a way, he's kind of liberating machines so that he obtains or steals or buys surplus machines from, there's probably a good market for it, from companies that just have nothing to do with these old industrial monsters. And then he's got the technical expertise to refurbish them and also resell them. Right now on eBay, he's got an auction for $150,000, I think is the going rate right now, that you can purchase a performance from him and his scene. He was kicked out of doing performances in San Francisco, his native performance plot where he started his notoriety, because the fire stations were just tired of dealing with him. So they proposed a bill that went through with San Francisco politicians that was pretty much just saying, like, the stuff that Startup Research Laboratory is doing needs to be legalized. And even San Francisco Fire Department, they keep tabs on what Mark's doing, and they call the towns that he's supposedly setting up new shows in, just to make sure the fire department knows that crazy stuff's going down. I recently bought his media packet, and it cost $20. I bought it like 3 months ago, and it just got to me. And on one hand, I'm like, well, why does it take so long? And on the other hand, it probably is because he blew his arm off trying to make rocket ship nitroglycerin equivalent, like rocket ship fuel. He tried to make it in his own backyard using like stolen documents about how to make like stuff that NASA uses. And he was supposedly doing making it. He said he had to cook it at 160 degrees for a couple days, and if it was 170 degrees, it would explode. And so after it was done, he one of the ceramic jars was kind of closed shut. So he just started tapping it with a hammer, and then it instantaneously exploded. All of his clothes burned off. His face was like covered in blood. Half of his hand was blown off, and he almost died. And so it's just a bunch of strange stuff. So supposedly from the aftermath, he just says like he's the kind of guy that can do very dangerous stuff, but he draws the line. He knows he's not able to do very, very dangerous stuff after that near-death experience. Strangely enough, he just happened to get this horrific explosion that happened to him right when local prosthetic doctors were working on some new experimental studies that would make it possible to graft his toes onto his hand. So now he had some of his toes cut off, putting onto his hand, so he has a gimp hand that has 2 toes, and they say it's the middle finger, the only finger left from the original hand. So he's deeply embedded in his artistic pursuit. And he's done like 40, 50 shows all across the world. The ones he's done in Tokyo were like publicly funded by big corporate giants. But out in America, he's hard-strapped to find a community that wants this stuff to happen. His earliest stuff, I think, is the most powerful stuff, because it was when he was doing theater that was intended for filming, so he was practically doing movies. So this one's got a narrative about some kind of crawling human versus a more mechanical monster. So his group's called Survival Research Laboratory. It's just a cover for him to do his crazy explosives and pyrotechnics. He made it a corporation because he realized that corporations have rights that humans don't. So whenever the fire show up and say, like, we're closing you down, all he has to do is say that, like, well, this is a corporate event, we're going to have to check with who's in charge, bureaucracy, it's going to take a while. Have your bureaucracy call my bureaucracy. these stage cinematographic pieces, I think are really effective. But he opted to do live performances, and everyone's got the same feel. Just murderous chaos, like kind of a half riot, half war, half Disneyland. So, you know, like an artist might have a bunch of sculptures all that have different names that are like the works that are the ones that he praises that are his masterpieces. For Mark Pauline, he's got this one, which is the 2x4 launcher. He just can't help but just want to put dangerous motors on wheels and then roll them around. So it's a little bit like choreographed ballet and a little bit like, you know,
Pneumatics, hydraulics,
destructive war.
everything related to robotics.
I like that one right there.
I did that many years ago. I worked at a robotics company.
The biggest critique against him is that it's just an expansion of kind of like the teenager boy desire to just destroy stuff and make homemade bombs and everything.
In 1987, and I was flown to New York City.
Shows like BattleBots came around because they tried to market
After that, every time there was a show, I would go.
market the work of Survival Research Laboratory to, you know, kind of dumb it down for the people to all understand.
Sort of an act of
That's
desperation.
him right there.
He had done quite a bit of theater work in college and really didn't really like working with theater people very much. But I like the whole notion of theater and the whole idea of setting up humans as these sort of mouthpieces for ideas you would want to get across. I didn't really like the experience of working with people as much as I liked the
Yeah, so it just launches 2x4s.
I am technology like
So humans are only involved as the audience. Everything's radio controlled. Usually like half the robots make it out alive, or half of them are intended to be destroyed. When he was 10, he was caught by police for trying to, well, actually accomplishing burning through a gumball machine with a propane torch. His first machine, or his first show was called Machine Sex, and it was a show, it was maybe like the George Bush eras or Reagan era, where like OPEC and like Saudi oil was this big deal, and there was maybe like American propaganda against Arabs. And so his show was, he took a bunch of birds that he slingshotted in an abandoned warehouse. He dressed them up in little suits that made them look kind of like Saudis. And then he put them on a conveyor belt and had them all approach like an industrial whirling turbine that like obliterated them into just like, you know, like goo. And then that was all displayed on like this inner sphere bubble, say like a 3-foot clear plexiglass sphere. So all the pigeon parts would just like turn into this action painting of death and whatnot. All during this, it was a improvised show where he just staked out a gas station that was closed on Sunday and that had available power supply, and he just showed up. So he's just like a guerrilla theater guy. I don't know, people like this, they're kind of dangerous because they don't have any respect for authority. They're controlled by a higher power. You know, they're going to do what they want, and if they get away with it, then they succeeded, I guess. But he was involved in the punk scene a little bit in bands and stuff when he was growing up. A lot of the propaganda he puts out as part of his publicization and commercialization are kind of like contradictory statements about being kind of like a docile slave to society, rather than inventing your own rules. William Gibson wrote about him in a book called Mona Lisa Overdrive. Called him like Slick Harry or something in the fiction adaptation. And when the protagonist asked Slick Harry about like what the world was about or why he's doing this stuff, Slick Harry said maybe how you've got to kind of either control yourself or the world's going to control you. You know, there's no such thing as like free will so much as either you're in charge or the world's in charge. Kind of like you have to race to be in charge of yourself. And then something else about how I don't know. What do you guys think about this? What are these machines here to do? It's a little bit like a breeding ground or like a rescue shelter for machines. In the Mona Lisa Overdrive book, he says, like, can you imagine a world where machines like this don't have to exist? And you know, all the atrocities of the world are played out by these machines in their original state, and he's just converted them into maybe their true self. But along those lines, there was this quote from Ballard, a famous dystopian. Such a straw. A famous dystopian writer, who's got a really famous book called Vermilion Sands that I want to read. And Ballard said robotics is just ethics for machines. It's like machines, you know, they're just out there to, you know, to kill or to destroy or to do their work. But all robotics has to do is to make it so that these uncontrolled machines are, you know, a little bit reeled in. So, I think next week we're going to get into electromy some more. I'm going to update my website so that will make more visual sense. Because right now it's just a bunch of text, which makes more sense to me than it would to someone who hasn't made all this art. But this board right here is just a bunch of concentric rings of copper. The outer rings are a binary encoder, so that if you roll past this point, then you're going to get that flickering energy. On this particular build, there's a concentric ring on all of the binary encoders, so that the copper pin would want to stay on the track that's changing and avoid this little string of constant power to get the energy signal. It's always tempting to try to compact as much information as you can into a little space, but there's this balance where you get to the point where there's more errors than there is any worthwhile meaning in compacting it so close. So just working with metal and loose materials and, you know, glue and wires, you can make these pins nestle, and you can try to get them to concentrically rotate. But they're always going to wax and wane. You're going to have like half a centimeter of tolerance. And so a system like this, it can really just bring you down if there's just a couple less rings, if each one was twice as big, and then you would never have to do any tuning, any calibration. It would just automatically work. So just work big when you do your first works. This particular board was intentioned to that when you spun it, that you get all the different permutations of this set of numbers, ons and offs. So every single line on this rotation is a different binary state if you add all of these binary digits up. So, you know, writing in binary, it's just a bunch of empty zeros. And each one of these is represented on here. There's 127 different states on this rotational board if you have those 7 pins added up. This one right here is these sprockets are pretty much the same thing, but they're just a little one-shot. So if you have this is a little pin, you can barely see that. It's just resting right here so that when it rotates, and it's going to get a flicker of that. This little model was originally just an automated fan, put it out in the wind, and then hopefully if the bearings are rolling correctly, each one of these will roll up whatever the wind wants, and then you'll get an electronic pulse that could be shown on some lights that are like right on the upper rim of this piece of art. So it's self-expressive. What I was trying to do next with these fans was make it so that the self-expressions of all the different signals would matrix each other. Matrixing is a principle that they use in pretty much every LCD design these days to make a matrix of lights, say 16 lights. All you need is 1, 2, 3, 4, 5, 6, 7, 8 wires. And with high-speed timing of microcontrollers these days, without even you knowing it, every second, there's a command sent to say 4 and 5 to make this one light on, and then all of them are turned off, and there's a command to say to 3 and 6 to turn this one on. And so they can send say 10,000 messages per second. And so they can do any configuration of these lights on and off. And they don't have to talk to every specific light individually. If you're going to do that, it would be 16 different wires. And then of course it gets exponential if you go up to 100 by 100 grid. You can control, say, 10,000 lights with 200 wires, which is a lot better than 10,000. So my idea for this one was you had 2 rotating boards, and you have these little ergonomic palm hands that rotate on them, and then it gets you any state. And then from these 2 boards, you can have a light board that was, one would have ground and one would have power. And you have any aesthetic light board you want. That's like a 7x7 grid. So you have 50 lights. And then you can get every single combination, maybe. No, probably not. Every single matrixable combination of individual lights on and off by turning these dials to the right position. A lot of my early work with circuit boards was about the spatial positioning on the circuit board. I have this one board where you have say 8 buttons, and the first one shines an outer rim of LEDs, and the second one goes in and shines this second rim, the third one the third rim, and so there's this spiral of lights. And so all you have to do is either manually touch all 8 buttons, or just put a sequencer that taps them all, and then you'll get the spiral of light. And the actual circuit board is a spatial spiral that has to move different coppers and keep them independent to get the energy to particular places. So I've got a whole slew of copper-clad designs that I've done. Most of them for touch interfaces. I'll show you some of the earliest ones, and then we'll just talk about the paper briefly. This one you can't see very well. Is an outer rim of energy. And then just these inner slits So if you rub your hand or a reader around, it'll just transmit energy from the outer rim to each one of the slits, and then the slits transmit energy to all those lights around the perimeters. The first one I did was hand drawn. So this was a hand drawing of a bunch of double spirals just to get all these pinouts to turn into LED flickers. I made a Max program that kind of automated the design of some of these, but it's more fun just to do it in Photoshop or copy and paste. So here's the one that I was mentioning on the board. Here's one that's kind of like the spiral one, but it's concentric rings. So here's the original drawing, and then here's it converted into kind of a spatial map. And just like in EMBODY, when you set up objects and they have collision detection, so it is with a copper board design. Is that it's practically just a giant collision detection system, and all of these particular zones have to be independent. They have to be spatially isolated. Otherwise, you're going to get a short, and then it's not going to do what you want. But luckily in Photoshop, you can just set shapes to be contiguously paint filled, and you can find out if the shapes are touching each other just with one paint fill operation. Some other designs. If you ever open up an organ, sometimes they have arpeggiator strips, which are just strips of power, and then all these different buttons. So you can just rub your hand past this strip, and then wherever you touch will output power on these taps. This one translated in here, the clover sprocket, and it's just a way of when you touch the buttons on the bottom, then you'll see like these long chains of copper go over here. So when you touch the bottom, the farthest one goes on, and then when you touch the top, the closest one goes on. So it was along the same lines as this one and this one, where you touch the left and then the energy on the right goes off. So it's like reversing the direction of energy. And this one does the same thing, but with a 180 phase shift. So every one of these lights rolls around to a 180 degree. Instead of on the left, it's on the right. This is what the heat sink designs inside of drum machines look like. If you ever open up a calculator, you're going to see these cool little pads like this, and they're just to maximize sensitivity, so that wherever you touch it, there's a chance that it's going to trigger the copper's transfer. Usually these are covered in a little suspended carbon rubber button. And if you think about it, like every touchscreen has a very minuscule one of these on it that's transparent, either for capacitive sensing or pressure sensing. These days they're so clear that they take like less than 10% of the light away from the screen. This was a design for a 2-layered circuit board. If you notice, it's got like the ergonomic design so that you can hold it with your 2 hands. Your 4 fingers extensions roll on this side, and then the thumbs can spread on this side. So you have like 30, 40 buttons. So it's kind of like a Nintendo gamepad, but just maxed out for like what you could touch on ergonomically on a 2-layered circuit board. But stuff like this was translating circles into squares. When you roll the energy off of a circle, then you play out a linear score. An example like this is a piece called Dangle Trigger, which had this chicken wire that was wrapped in steel wool, and then suspended in each one of the holes was a dangling music wire. So the system like this, you don't have to introduce electricity to it. All you have to do is perturb it or give it agitation, and then the electricity transfers for you. Here's an example of coating chicken wire with steel wool. This was the design for my light record player. I think it's what started the concentric art for me, kind of like the roto reliefs from Duchamp. The coolest thing to do once you design a platform is that you modularly create the input devices. So these are a bunch of different algorithmically designed or photo transfers. Half of them like this that look kind of like Northwest Indians or Midwest Indians are from Cellular Automata, which I think I'll talk about more next week, where you just create feedback patterns based on cell operations. Basically, it's like for your next, each line generates the next line, and there's rules based on like how many neighbors are bright, depends outputs like if you're bright or not. So you can print all these different records, and instead of using copper or laminate, you can just use metal and then print paint on them, and then the paint acts as an insulator. So as long as you only want one electric signal to be dispersed to many places, you can just use metal and paint it. Yeah, so last thing today is a little bit about our paper. You got to email it to me or hand it in on actual paper by the 28th of August, which might be the last day of the meeting. I forget. But it's Wednesday. But what I expect from you to fulfill this class's written assignment is 2 little papers, like two pages each, so it's like 3 to 5 pages total. And you got 2 prompts. The first one, they're pretty straightforward prompts, up to you to divine what you do with them. Choose an artist or an art movement that you will research in a short paper. Suggestions are anyone I've talked about in class. And if you got someone out on another branch of art or technical expression, just mention it to me and we'll see. It probably is good, just want to find out where you're going with it. So choose an artist or art movement. Artist may be Calder, Tingale, Mahalanaj, Noam Gabo, Rodchenko, or all these guys that I like to talk about, but it's up to you. Or choose an art movement, or both, because pretty much every artist is part of one art movement or more. Russian constructivism, Russian futurism. Cubism was around Europe and Spain. Abstract expressionism was 1950s America. Guys like Jackson Pollock that are like doing gestural art instead of representational art. Or op art translates into kinetic art pretty closely. So yeah, any artist or art movement. And by artist, you could go ahead and choose scientist, you know. And for the prompt number 2, another page or 2 of work, you have to discuss kinetic art or KineMATICS spatial theory. Kind of like the 2 versions of what we tried to communicate in this class, you know, art based on movement or machine design based on the spatial awareness of components, almost like consciousness. And so you got to discuss kinetic art or KineMATICS spatial theory and its intersection with your major. So it's, you know, fine-tuned to whatever you want to do with it. So I thought for film technology, you could talk about how the actual camera used to be a mechanical machine before it kind of branched out and turned a little bit more digital than mechanical, perhaps at this point, where the optical eye is just an array of sensors. For robotics, mention again how Ballard called robotics just teaching machines ethics. And then if your major's art, maybe think about spatial balance as a modern language. It used to be that you look at a composition, a portrait, and you're like, that works, that looks balanced. But with kinetic art, gravity itself is making that decision if it is balanced. So meaning is inherited from natural forces. The properties of light are more directly interacted with in kinetic art because you're manipulating it as a primary material rather than just kind of like a side effect of the paint. So yeah, type it and email it to me or hand it in by the 28th, might be the last day of class. Ideally 4 pages, and just to make sure that you're on a good a regiment of research papers, I just want you to make sure that you include 3 references, so you have to have a reference page. And it'll make it really easy for you. You gotta do an online reference, you gotta do a library reference, aka a prestigious long-winded tome from McHenry or Science Library, and 1 personal reference. On my thesis for Janum, one of my references was Wikipedia, and they laughed at me, but it still got me through. But another one of the references was I just tracked down an artist that I was inspired by online, and I just started an email chat with him and got some ideas from him, and then just directly that email turned into a reference. And you can go on like the Sena Citation website to automate the making of your reference page, and they have a menu for if it's an email. There's like 100 different types of references that are plausible these days on papers. But by the time you get confused about what you're supposed to do for this paper, you're probably done with the paper because it's only about 4 pages. So we got like 2 weeks left after today. I emailed Jude about getting a passcode for the room, and supposedly Bruce is not really on duty these days, and he's the one with the number, so he might get back to me for next week, hopefully. But we're done here, so